solve the equation. It has two radicals in the problem. It does say to check your solution, so we are going to check to make sure they both work. But notice you have a radical on each side, whereas the three problems, or four problems from your homework, the last four like Chris did, like the one we just did, 39, there's only one radical in the problem. So now there's two. So two radicals mean lots of fun. So how do you think you would solve a problem with two radicals? What do you think you'd do first? Yeah, we're still going to square root both sides. So the first step is to isolate the radical. If there's two radicals, we can't really isolate them. So the only option is to try and get rid of one of them by squaring both sides. Now when you square both sides, again, this plus sign makes them a partner, a pair. They're grouped together. They're a quantity. So you can't individually square pieces, because it is a group together held with that plus sign. So they are now a quantity held together with the plus sign. So when you square it, you're squaring that group, that pair. On the other side, we can square that as well. So remember, our goal is to solve this to try and get x by itself. Well, we need to try and get rid of the radicals first. So, Peter, if you square the right side, you end up with 10 minus 3x. So that's good because the radical and the power cancel each other out. However, on the other side, you're squaring those two things. And I'm going to write it out because that really means you're taking x plus 6 plus 2 times x plus 6 and then plus 2 again. So when something is squared, it really means it's doubled. There are two of them. So we have to FOIL this. And it's a little different than just FOILing things that don't have square roots. So just be careful. So when we FOIL our first terms, we have the square root of x plus 6 times the square root of x plus 6. What's that become? Peter? Yeah, just x plus 6. So these guys, because I'm multiplying a square root by the same square root, they cancel out. So when you have a square root and you multiply it by the same thing, those are canceling out as well. So that's x plus 6. So that's good. But then when I get the outer terms and the inner terms, this is where it's a little different. I have the square root of x plus 6 times 2. And another 2 times the square root of x plus 6. They don't cancel. So again, I'm going to write it out so you can see what it looks like this first time. So I have the square root of x plus 6 times 2. That means I have 2 times the square root of x plus 6. That's what that outer term is. The inner term is 2 times the square root of x plus 6. So I really have that written twice. And then the last terms, 2 and 2 multiplied to be 4. So, again, the square root of x plus 6, square root of x plus 6 cancels. But then when you're multiplying the square root of x plus 6 times 2, that 2 goes in front of the square root, in front of the radical. So on the left side, if you try and pull some things together, group your like terms together, what would you have on the left side of the equation, Chris? Yeah, so we have the 6 and the 4, so he said that makes x plus 10. These are like terms, so you add the numbers in front and you get 4. So try and think of like what we've done yesterday, what you did in your homework. How do you think you'd continue to work through the problem? So there's still a square root in there. So what do you think you would do next? Jack? So he said you could take the 10 minus 3x to the other side. Or, Jack, what else could you do instead of taking it so that everything's on one side of the equation with the radical? there's still a square root. We want to try and get this by itself. What would be the other option? Right. So if you have a radical that's still in the problem, we still need to isolate that radical. You're still trying to get the radical by itself because that's what we need to get rid of. So instead, we'll take the x and the 10 to the other side. So we're subtracting the x, subtracting the 10. Isolating the radical, because there's still a radical in the problem. So we still have 4 square root x plus 6. Over here, it's nice, the 10's cancel, and we still have then just a negative 4x. So we're getting closer, but there's still a radical. And the radical isn't isolated yet. So what do you think you would do next? What would the next step be? Nina? Yeah, so isolate the radical means if there's still something with the radical, we need to get rid of that part too. So if you divide by 4, it works out really nicely when you divide by 4, because on the other side we just then have a negative x. So now you have a square root on one side. We have the negative x on the other. Right, raise it to the second power. So see if you can continue to solve. So this is now a problem like you had from Crumworth last night. But it's like a multiple step problem. And then after you get an answer, or multiple answers, make sure that you check your work. And be careful with that x squared. It's a negative x squared. When it's a negative x, it becomes a positive x squared. We're squaring the x and the negative. And then this is x plus 6. So it's a really long problem. It's not just a one step where you're squaring both sides. There's 2 radicals, so you have to do it twice. JT, what 2 numbers multiply to be negative 6 but combine to be negative 1? 2 and 3, so a negative 3 and a positive 2. So 2 answers, a positive 3 and a negative 2. So you got through the whole problem, did a lot of work because you FOILed twice, and then you factored. You had to get rid of 2 square roots, so that's why you ended up having to FOIL twice. But you're not done. Make sure you go back and check. So they both could work. One of them might not work. Both of them might not work. It would be really horrible if you did all that work and then both problems don't work. But go back and check it into the original problem. So going back to where we started, plugging in the 3, you're now plugging it into both sides of the equation. So we're plugging in a positive 3, the square root of 3 plus 6 plus 2. On the other side, I have the square root of 10 minus 3 times 3. So Michael, on the left side, what do you end up with? And on the right side, you get, does 3 equal 1? Never. 3 never equals 1. So that definitely does not work because 3 does not equal 1. So 3 is not a solution. Making sure the second one is a solution, plugging it in again. So we have negative 2 plus 6. On the other side, 10 minus 3 times negative 2. Sorry, that got a little tiny there. So Dimitri, over here, you end up with 4, and on the other side, also 4. So 10, and then negative 3 and negative 2 is a positive 6. So we end up with the square root of 16, and over here we also end up with the 4. So that that means the 2 is the solution. So that's a lot of work. Great problem. Makes you do a lot of algebra. Questions? So I think there's another one like this, but I'd like you to flip to the back because I wanted to look at letter A. As I was walking around seeing some problems with the radical exponent, rational exponents, making sure everybody understands how to isolate, and whether it's a square root or an exponent, the part that has the power to it needs to be isolated before you work with the radical. So if you look at letter A, it says solve the equation, check for the extraneous solution. How would you isolate the radical? What do you have to do first? Chris? Right, so we first need to add 21. Those are like terms. Combine them together. So we're not doing anything with the exponent right now, which will eventually become a radical. Not doing anything with that part. On the other side, Chris, negative 53 and 21 make? And again, you still need to isolate it. So before you do anything else, get rid of the negative 2. Hi. I just kept rebooting it, but 3 times didn't work. 3 times didn't work. It was like 7 or 8 times. But I left it, like, I just left it for half an hour. And you know about the lag time. So we have x to the 4/3, which really means what? X to the 4/3. What does that really mean, Peter?
Cube root or negative 2 cube root of x to the 4th.
So make sure you divide first by the negative 2. Divide first by the negative 2, yeah. Okay. So we have the cube root of x to the 4th. So whichever way you choose to kind of solve the next step, we need to get rid of the cube root. And we need to then take the 4th root. So however you choose to proceed, whichever step you do first is up to you. So whether you take the 4th root first or you do the cube part first. So I cube both sides to get rid of that, and I just left it as 16 cubed. So Nick, what is the 4th root of 16?
2.
Only a 2?
2 cubed.
Only a 2 cubed? Cool.
2 and negative 2.
Why is it 2 and negative 2?
Because 4 is a negative number.
Excellent. This guy right there. That's the trick. Gets forgotten about. If it's an even root, it's a plus or minus. If it's odd, it's just whatever the number is once you take the radical. But that's the trickiest thing to remember. So even, nice job, Cole, means you have a plus or minus. So you have a positive 8 and a negative 8 as 2 solutions. Make sure you go back to check to see if they work. Both of them do work, but make sure you check to see that they both work. Questions? You will have one like that on your test. At least 5 of you will forget the plus or minus. It just happens. So you did all the work, and then you forget that last part. Peter's saying you're not going to be one of them, right? You might be one of them.
I usually forget about that.
Yeah, and you know what? It still happens. It's gonna happen. It's one of those things that you did all the hard work and then you forget about that last part of the answer. So on this worksheet, I want to actually start number 18 with you because number 18 was like the big problem that we did. I just want to get you a little start on it. just the odds on the front page. I have the solutions posted to Google Classroom, so the odds on the front page. On the back, also just 11 and 13, actually just 11 on the back. And then you can start at 13 and do the rest then. Yeah, so 1 through 11 odd. I'll write it up here. And then 13 to 20. And I want you to look at number 18. So this is what number 18 says. And I would just give you a little fair warning. You might want to do number 18 with a separate piece of paper or write really small. Really small. So some of you can write really small. And neatly, that's fine. But you might want to do number 18 and number 20. 20 at least has a little more space underneath it. But those would be the two big problems, 18 and 20. Peter, what do you think first?
Well, I wrote the most radical.
Yeah, and that's what I would say. So if you have something as an exponent, change it to a radical. So if we're solving this, it really means that we have the square root. That's what a 1/2 power is. So 1/2 power is a square root. A 1/3 is a cube root. So change it to a radical first. So that would be the first step. If you see an exponent, make it a radical. Now there are 2 square roots in this problem, just like the big problem that we did. You need to get one of those square roots on the other side. Peter, which one do you think you would move?
Negative.
Yeah, you might as well move the one that's negative. So this has a negative in front of it. We're literally going to add this whole thing to the other side. And you might as well choose the one that's negative because then you have positive problems, positive radicals on both sides. But we're going to literally take this whole thing and add it to the other side. So you're not changing the stuff underneath. You're just adding that whole piece and moving it to the other side. So we have -3 minus 4x. And then there's the 1 with the plus sign, and then -2 minus 2x. So we made it a square root. We moved one square root to the other side. There's still a whole bunch of negatives underneath. Now, how would you proceed, Chris? Right. So now you want to try and start getting rid of those radicals. So square this and square that side. So the left side, bless you, cancels. The right side, when you square something, it means there are 2 of those quantities. And then you're going to have to FOIL that. This is the hardest problem on the worksheet. Number 20 is similar to this problem. I don't think it's quite as involved. So you have about 7 minutes. See if you can, if you want to continue on with this problem while you're here, fine. The front of the worksheet's pretty straightforward and easier. And I'd say like even some of the back worksheets. The last couple of problems are the ones that are a little more involved. So again, 1 through 11 odd, and then 13 to 20. The answers are posted to Google Classroom. Tomorrow is your notebook quiz on chapters 5 and 6. And then we'll start reviewing tomorrow, and we'll review Monday for 6 chapter 6 tests.
You have to do it motion.
Yes.
You have to do 2.
So you'll have to FOIL twice for this problem. So anytime there are 2 radicals, that means you've got to FOIL twice.
That's it. Okay.
So I did the first set of foiling for that problem too up here. I also have this problem worked out on Google Classroom as part of the solution.
Should be root becomes the pi of x squared plus 2x. Wait. Yeah, I hear x squared plus 2x plus 3. Over. Because there's the negative x squared. So what did you get when you foiled negative? That's what I got. I got x squared plus 2x. Yeah, that's right. I'm forgetting to write